Hi, everybody. Hi, Krystal. Climate Emergency Month is nearing pre-planning completion. Soon we'll be sharing information about many activities and events on campuses and in the community and across Southwest Michigan, both in person and many on Zoom. Watch for those across multiple platforms. You may find a way to participate and host a new event yourselves. Stay tuned. I may share the link in the chat during the meeting. Thanks.
Okay. Tim?
And this is looking way ahead, but the Michigan Eagle has just announced their conference on the Michigan Healthy Climate Plan, which will be in person in April in Detroit.
Okay. And in line with the climate emergency at the Julie Rogers meeting today, we mentioned it, and she said that she would also put it out to her constituents that it's happening. So hopefully it will get to a wider audience. Okay. So now it's after 2 o'clock. If there are no after 1 o'clock, sorry, it was 12:02. 2 was on my mind. And if there are no more announcements, let me introduce Krystal. She wrote up an introduction that I can use. Dr. Krystal York earned her PhD in electrical engineering from Western Michigan University in 2022, and she's currently working as a researcher at Electric Power Research Institute. I think that's a great place to be since we keep talking about electrifying everything, and hopefully this institute will help us figure out how to do that. She's going to be sharing the basics of hydrogen, what the different colors represent when we read about green and blue, et cetera, and the hydrogen's possible role in a clean energy future. She will also cover safety and environmental justice considerations. Safety is something my generation might think about because we also grew up hearing about the Hindenburg, even though it was before my time. And so safety has always been one of my concerns about hydrogen. So with that, as an introduction to Krystal, she's going to be talking to us now. And if you have any questions, put them in the chat. We'll try to get to them at the end of the talk. Krystal.
Hello. Can you see my presentation? I will begin. Cool. So that works.
We can see all your slides though too.
That's okay. I'm about to hit play from start, and hopefully that is good. Cool. Cool. Okay. So like Nikki said, my name is Krystal. I graduated from Western Michigan University back in April of 2020 with my PhD in electrical engineering. And now I work for a nonprofit researching decarbonization solutions, mostly focused on hydrogen. So that's what we're going to be talking about today. So what is hydrogen? So I mostly say this just to say that when I talk about hydrogen throughout this presentation, it will be mostly be referring to the molecular hydrogen, so H2, not the element just H. That is because it doesn't normally exist just by itself. It usually combines with something else to form a molecule. So it is the lightest element and the most abundant element in the universe. But like I said, it's most abundant element, but it's almost always with something else. So, and because it's the lightest element on the periodic table, when it is in molecular form, it has a lot of special, interesting, and sometimes hard to work with properties. So one of those properties is that it has a low volumetric energy density. And that just means that you need a lot of space in order to store hydrogen as energy. So that is one of the problems that comes into play when you're working with hydrogen. It needs a big container in order to store it. It can be, another property is it can be liquefied, but it needs to be cooled and put under a lot of pressure in order to do so. So you can change it into a different form. One of the main properties I want to point out on this slide, though, is the small molecular size. I already said that it's the smallest element, and that means 2 hydrogens would make the smallest molecule, and that means it can more easily leak when there is some sort of pathway for it to leak. So for example, if you put hydrogen in natural gas pipes, that would not be ideal because natural gas pipes are made for natural gas, and hydrogen can leak more easily through the natural gas pipes. And we already hear about natural gas leaking in the atmosphere and then causing methane emissions. So yeah, that is one of the problems, but there are specific hydrogen pipes made for hydrogen, and I'll talk about that a little bit more later. The last thing I want to say about this slide is that although it is non-toxic and it doesn't produce carbon emissions, when you combust hydrogen, it does produce what's known as NOx, which is made of nitrogen and oxygen. And you may have heard of NOx emissions, especially recently. It's been talked about because NOx emissions are also made when you combust natural gas too. So if you had a gas burner, there is NOx emissions being outputted by that, but hydrogen can produce more NOx emissions than combusting natural gas.
Krystal, could you
yeah.
switch to a slideshow view?
Oh, yeah. Do you not see that? Wait.
Well, we've seen, there we go.
Oh, I thought that's what you were seeing in the first place. Okay, my bad. Yeah, so now how is hydrogen made? Hydrogen can be made in a lot of different ways, but right now hydrogen is mostly being made in that using natural gas. Oh, I didn't mean to do that. So hydrogen's mostly being made using natural gas, which is bad for the environment. And there's also other ways. Another classic way that it has been used is coal. But what we are trying to do is move over to making hydrogen using electrolysis powered by renewable energy sources. Electrolysis is a technology that if you hook it up to some power, feed it some water, it will split that water into hydrogen gas and oxygen. So that is a theoretically that is a zero carbon process to make hydrogen. Whereas right now, if you're using steam methane reforming of natural gas, that involves a lot of carbon emissions. So currently, some people don't know this, but hydrogen is already being produced and used throughout the world. All throughout the world, it's 94 million metric tons of hydrogen is being made. Typically, like I said in the last slide, it's mostly being made using natural gas, with the second amount of production is coal. And that's because they're currently the cheapest methods to make hydrogen. So that's what a lot of people focus on, is whatever's the cheapest usually is winning out. But like I said in the last slide, both natural gas and coal using it to make hydrogen produces a lot of emissions. So we're trying to move away from that. And like I said, it's being used throughout the world as well. Right now, the United States uses about 10 million metric tons of that hydrogen being produced to make different things. Most of the time, hydrogen is being used as the molecule to make it into ammonia for fertilizer, or to make it into gas, use it as a feedstock for gasoline and diesel fuel from crude oil refineries. So those are the top 2 uses. There's a couple of smaller uses. And because hydrogen is being used, there is already infrastructure for it. Most of that 16,000 miles of hydrogen pipeline is in Texas in the United States. There's a couple other spots here or there, but it's mostly in Texas along the Gulf Coast. And then along with the caverns, the 3 caverns, you can store hydrogen in caves. Those are also around the same area. So since we are, this is all to say that since we already have and are already using hydrogen, we know how to use it. And so we're not starting from zero when we're trying to use hydrogen more. Yeah, and so I mentioned this before, and this is for mostly just for people that really, really want to know the chemistry. But all this to say is electrolysis is what we're trying to move towards. You use these electrolyzers, let's say just for simplicity, you plug them into the wall, you feed them water, they split it into hydrogen and oxygen. Yeah, that's the general gist of it. I could go into the chemistry, but let's not. But also this slide is to say that there are 4 main types of electrolyzers. The 2 to the left of the screen, alkaline and PEM, are the most mature of the technology. Alkaline dating back like 100 years actually. PEM is a lot newer. And then the solid oxide and the anion are more not in the market yet. So they're just newer technologies that are in the R&D phase. So, electrolyzer hydrogen production in the United States. Now, I want to say that this is most of these are under construction and most of these are very small, but this is all to say that the United States is becoming more interested in this technology. But yeah, like I said, most of the capacity that is on the screen is just under construction. So now to switch towards why we may need hydrogen. Most of that is because there's a lot of pathways to decarbonize industries, but not all industries can be, for example, electrified. Some of them are harder to electrify. And I will go into some of those details. But I like to say that we want to start from the top method and go to the bottom. Efficiency, taking advantage of how we can make our processes more efficient, our material use more efficient, using less materials, recycling, reusing things, and also technology, using the electricity more efficiently. Electrification, we want to move towards electrifying everything as much as possible, but some technology, it's either very hard to electrify or nearly impossible. I like to give the example of steel. Making steel is very difficult without some sort of combustion process. And then my least favorite option, but maybe somewhere down the line, we could talk about carbon capture and utilization and storage, but we'll see. So talking about the different steps in the hydrogen process, I want to point out for this slide, the main point I want to make is that you can plug in, and let's say plug in an electrolyzer just to the grid to power it, but that grid as of right now is mostly being powered using natural gas, as most of us probably know. So there is a way to make hydrogen using electrolyzers, but not in a clean way. So we want to focus on putting more renewable energy on the grid if we do want to plug electrolyzers on the grid, or just directly using renewable energy with those electrolyzers. So that's a point that is very important to make. And also just basically like we we're already making renewable energy a lot cheaper, but if we scale more, we can make it even more cheaper. So we need to put a lot of renewable energy on the grid. And that could decrease our electricity costs along with many other benefits like the environment. So then it powers the electrolyzer. And all of these details are just in case you really like details like me, but I like to point out kind of what's in the middle of that, that decreasing the amount of platinum group metals used. So those are very rare metals that can be bad for the environment to mine. You've probably heard that they're also in lithium-ion batteries. So if we could decrease the amount of those metals, that could not only decrease the cost of the electrolyzer, but also decrease the environmental footprint. Because we got to think that just like solar power, just like solar panels, just like batteries, electrolyzers, there's also some sort of carbon footprint with the actual making of the product. So we can't forget about that. And then storing the hydrogen. So storing the hydrogen is a thing we need to consider. It's mostly logistical issues with that, but you can store them in gas containers, pressurize them, store them in those containers, or you can store them in caverns, like I mentioned earlier. That's a way to store hydrogen in a store a large amount of hydrogen. So that's what a lot of people are trying to look into. And I would like to, I like to say that that's probably the more beneficial use, because unless you it's just a lot of logistical issues. So yeah, and I will talk more about why salt caverns could even come more into play in a little bit. But also once you make the hydrogen, you store the hydrogen, you also need to transport it to where it needs to be used. Now, hydrogen, the cheapest way to transport hydrogen, or any gas for that matter, is pipelines, but there are already storage methods using trucks. Tanker trucks are what they're called, but nobody transports hydrogen using planes or shipping right now, but they are looking into shipping, not so much planes. But the reason I put both of those in there is because people are looking at powering the ships, powering the planes using hydrogen, not using them for a transport method, using the hydrogen to power them. So there's a difference there. You can hear a transport method versus a use. But those are, especially planes, that's very far off. But it's a possibility. Yeah, and then other industries that are being used as an end use are in the steel industry, like I mentioned. You combust hydrogen to produce that high heat to make steel. It's already used as a feedstock in ammonia and fertilizer and other chemicals. So it could, instead of using the hydrogen made in that carbon intensive process, you could make the hydrogen that is needed for ammonia in a cleaner process. And then the whole end product is a lot cleaner. Yeah, so those are some of the common end uses. Oh, and I said you can power ships with it. They are looking into that, but they're more looking into using the clean hydrogen, making the clean hydrogen into ammonia, and then using ammonia to power the ships. That's just because, like I said in the beginning, hydrogen takes up a lot of space to store it, and you don't want all of the storage space on a ship just be taken up by hydrogen. So to save on some of that space, they're converting it to a more energy dense molecule, ammonia. Yeah. So I said there was a lot of logistical issues, especially in this middle part, the storage and the pipelines. But there's one avenue that a lot of people are looking into to decrease the cost of the use of hydrogen, and that's to put all of this in one place. So there was a less need for the storage and the transport. So if you were to generate the hydrogen at the same place you are using the hydrogen, there's less need for that infrastructure in between. So hydrogen hubs is a whole system design approach to reduce the need for storage, as I was saying. And also, I don't know much about regulations and the regulatory agencies, but people also say it would ease pressure from the regulatory agency, because if they're just going down the line and at one location confirming, yes, this is safe, it might be easier to confirm that the next thing is safe too. But I don't know much about regulations. Yeah. And then where to build the hubs. This is just all dependent upon how to make hydrogen cheaper. For example, if you build it where renewable energy is cheapest, so in sunny areas, let's say, that could reduce the cost of the end product. Near ports for shipping is a common one as well, so that you could easily transport the hydrogen to other places that may need it. And there's already some infrastructure in some ports to store gas, such as hydrogen. So that could also be good. Or at a place that we want to decarbonize, so near steel industries, let's say, if we built these hubs near a steel industry, we could more quickly decarbonize that area. Yeah, where there's already current pipeline infrastructure, that would just basically be in Texas, near the Gulf, which also checks off the ports for shipping. And then finally, where it will have the greatest impact. Maybe it's near communities that have been disproportionately impacted, let's say, and there's a heavily carbon intense industry. We focus on that community to decarbonize the industry, and then it improves their air quality. That's just a very quick example that I thought of off the top of my head. But yeah. Oh yeah, and like I said, the United States is looking into this, and this is just an image that they made saying like this area would be good for a hub because of these reasons. So there's not many areas that would cover all of the benefits, but some of the areas cover some of the benefits, I would say. So yeah. Potential end users. So that's that. I've already kind of talked about some of this, but that's those chemical industries. The ammonia industries is already being using hydrogen. So that's a quick, easy replacement. It doesn't matter how you make the hydrogen, the molecule looks the same. So if we were to replace the hydrogen with cleaner hydrogen for those industries that are already using it, one-to-one replacement, basically. Another thing I like to point out with this slide is that forklifts are actually another technology that's already using hydrogen. There's hydrogen fuel cell forklifts already in the industry. So there's a use there as well. I also like to say with this slide is that although light duty vehicles is on the slide, I doubt we're going to see many fuel cell vehicles. It's mostly going to be electric vehicles, but you could see more heavy duty vehicles that need a faster refill. Let's say like the charging infrastructure, it can't charge the batteries fast enough for the heavy duty vehicles. Maybe there's a place for hydrogen with heavy duty vehicles. Yeah, and then I will talk about distributed generation backup power in a second with a different slide. But like I said, there's still a lot of demands and a lot of problems we need to solve in order for this to happen. Oh, and then the final thing I like to point out is up in this top right, it says low percentage hydrogen blending. There is an ability to blend hydrogen into natural gas pipelines, but that's probably my least favorite use of hydrogen because it extends the life of the natural gas infrastructure. So a lot of gas utilities are looking at blending hydrogen into their pipes to offset that little bit of natural gas. So instead of let's say the most that people are saying is 20% blend of hydrogen. So if you put 20% of blend of hydrogen, it's a little less natural gas you have to put in the pipes. They're saying that's better for the environment. However, if you blend only 20% of hydrogen in a natural gas pipeline, that usually they're saying that it offsets only about 5 to 7% of the carbon emissions. So that's like barely anything. And it's really hard to blend more than that because of how small the molecule is, how the pipelines aren't created for hydrogen, need to switch over that infrastructure. Yeah, so I like to say all that as like, that's one way that gas industries are looking into, gas utilities are looking into decarbonizing, but is it really decarbonizing? So that's important to remember. And yeah, so there's different phases. We'll start with the phases over here, offset hydrogen and forklifts and refining and clean ammonia, and then move towards other industries that aren't using hydrogen as much. So this is just an image from the DOE saying that not all of this is going to happen at once. It takes a while. Yeah, so I talked about reducing emissions. So because hydrogen does not have that carbon element in there, there's no direct carbon emissions when combusted, but you still have to worry about other things such as how did you make the hydrogen? Yeah, and then economic is a possible other benefit. You can make more jobs possibly. You would have to make sure that the jobs that might be shutting down are transferred to the hydrogen industry. So you need to build in some educational infrastructure there, but there's a possibility that it could increase jobs, some people are saying, and increasing the amount of renewable energy on the grid. If we're going to make hydrogen green, we need a lot more renewable energy. We need to cover the current electricity demand with the renewable energy and then focus on offsetting any extra renewables with making hydrogen using that power. But we don't have the extra renewables in many places yet. Yeah, and then a balancing asset, which I have a slide talking about that some more. But basically, if we finally do get to that point where there's a lot of renewables and there's a peak in the renewable curve where the amount of renewable energy offsets the demand for that renewable, or yeah, the supply is greater than the demand, then you can use that little bit of extra supply to make hydrogen instead, store it because it's actually more easily stored. Well, not more easily. I would say it can store for longer and be used for longer than battery storage. So you could do that, but there's also a place for battery storage. I'm not saying it'll replace it, but yeah, so using that supply that is greater than the demand, making hydrogen, storing it for later. This is not much to do with hydrogen. This is just saying that we have emissions from all of these industries, and much of these industries, we could offset some of those emissions using hydrogen. So I've talked about transport, there's some electricity generation, industry, agriculture, and commercial buildings. There's all of those little places hydrogen can come into play in different areas. And this is what I was just talking about with the balancing aspect. If you look at this graph to the right, there's more, that red area is representing more solar energy, so more supply than demand, which can happen in the middle of the day in sunny areas. So all of that solar energy would be put to waste unless we stored it somehow. And so hydrogen can store it and then fill in the gaps later, or batteries can store it, fill in the gaps later, and so on. This is just a list of challenges. Some of them I've already said, and some of them I will continue to talk about, like the safety is up next. The safety is the next thing I'm going to be talking about. But yeah, there's a lot of cost challenges. There's a lot of water challenges and storage, and I talked about the logistics with the storage and transport. Are there actually people that will buy your hydrogen at the end? You have to worry about that. And you have to worry about the safety, environmental aspects, and environmental justice considerations. So yeah, that's next. Hydrogen safety. So I said it's a small molecule, so that means it can leak more easily. Also, another thing that causes leaks is that it can embrittle metals. So that just means that it can weaken the metals, basically, because the hydrogen can weaken steel, some parts of steel, and then that causes cracks, which causes leaks. Flammable explosions. So I like to say here that the way that hydrogen explodes is if there's a leak. And so if you prevent the leak, it's not going to explode. And people are using hydrogen in Texas right now every day, and we're not hearing about hydrogen exploding in Texas all the time. So, and even when there is a leak, that doesn't guarantee an explosion. There are safety, there's detection methods that if you detect it fast enough, the detection methods completely cut off the supply of hydrogen. But yeah, that's kind of what I'm talking about here, some mitigations to all of those hazards. Because there's hazards in using any gas or energy, because if you're storing energy, releasing that energy can cause problems. Since we already use hydrogen, there's already hydrogen standards in place that you have to follow. There's already hydrogen leak detectors and exploration into more effective leak detectors. The one that concerns me, I wouldn't say the most, but it's a concern that a lot of people might not know about, is that when you combust hydrogen, it produces NOx emissions. I've talked about this a little bit, but there are explorations into different technology that can reduce those NOx emissions, such as selective catalytic reduction systems and new burner designs, and a lot of different designs, new turbine designs and such. So although there's hazards with a lot of things. You got to build your system towards those hazards. Yeah. So how dangerous is hydrogen? This is what Nikki was talking about. I wouldn't say I said myths here. Some of those are myths. Some of them have some truth to them, obviously. But the Hindenburg, I like to give this example. There was the Hindenburg, but there was a sister ship called the Graf Zeppelin, which was flying even before the Hindenburg, flew many more flights than the Hindenburg, never exploded, never did anything like that. It's because there was a lot of safety cuts that were made when using the Hindenburg, and that is maybe one of the reasons why it exploded. They actually never really confirmed exactly why it exploded, but the hydrogen definitely, whatever reason it was, hydrogen did not help. So all this to say is you have to be very careful. You have to build your system to it. You have to put in safety regulations. And yeah, some people think the Challenger shuttle exploded because of hydrogen. That is not the case. It was a seal issue, I think, or an O-ring. It was an O-ring issue. Use of hydrogen is so new. Like I said, we've used hydrogen for a while. We have regulations in place. We use it in Texas a lot, for example. And then fire and explosions will definitely happen. Hydrogen doesn't just explode by itself. It needs an ignition source. The problem is that hydrogen's ignition range is wider, so it's easier to ignite that flame. Easier to ignite the gas into a flame if a leak does occur. So yeah. And then this is my final slide. And I like to end on this because I like to say that although hydrogen could possibly do some good, there are a lot of concerns being raised by community organizers, and those concerns are valid. The ones that I haven't talked about as much that I would like to draw attention to is the green hydrogen, making green hydrogen. A lot of people are concerned that we're going to use the renewable resources to make green hydrogen instead of using them to power things that need to be powered, like our homes. You need to go in that order. You need to electrify everything and then use that extra power to make hydrogen. Blue hydrogen, I didn't really talk about too much, but blue hydrogen, I meant to mention a little bit more. It's using the traditional process, I guess, the steam methane reforming, and then just carbon capturing that any carbon at the end that comes off of the natural gas. That is a way that a lot of fossil fuel companies are looking into. So maybe that's not the best way. Maybe we just want to make green hydrogen. And another thing I didn't mention is the global warming potential. There is a slight global warming potential if hydrogen does leak into the atmosphere because of how it combines with other gases in the air. But it's definitely not as much as when methane leaks, that's for sure. But still a problem that we need to address and a problem that we need to mitigate. Oh, and I didn't talk about the use of water. There is some water usage in making hydrogen. It is actually not as much as you would think, but making hydrogen in drought-filled areas might not be the best option, but just something to consider. Yeah, I don't know. Any questions? I know I just spit out a lot of information at you. Oh, the last thing I wanted to say is that NOx emissions. I talked about this already. When you combust hydrogen, it creates NOx emissions. When you combust natural gas and methane, it also creates NOx emissions, but hydrogen does create more. But if we use hydrogen in fuel cells, it doesn't create NOx emissions. That's an important distinction there, because that's more of an electrochemical process, not a combustion process. Yeah, I felt like I talked a lot, but.
Okay. There are a couple of questions that came through. Could you explain what feedstock is? You used that on one of your slides.
Yeah, so that is a word that people use as basically an ingredient. So that's how I would describe it. Hydrogen is an ingredient in making natural gas, but you need, in ammonia. So that's NH3. You need to use hydrogen gas and nitrogen to make ammonia. So it's basically just an ingredient, a fancy word that people say. It's also an ingredient in chemicals. So there's a lot of different chemicals that have, like, just cleaning chemicals, let's say, that have hydrogen molecules in it. That would be another way to use hydrogen as a feedstock or an ingredient. Yeah.
Another question is, what modifications would be required if we want to retrofit the gas pipeline infrastructure, and can we?
Yeah, they're looking into that a lot. It would cost a lot of money. You can do it. It's not impossible. People have done it to short areas of pipeline before. People have done it in labs, but that's just research areas. There's different ways people fix pipelines too. How they fix them for natural gas, where I've heard of, like, if you have a really big pipeline, you can feed something inside of it, which would be that inside part would be fine to feed things into, but the outside part is not broken. but because that space is already cleared out, it's easier than digging more area to put pipeline in. So yeah, you can retrofit natural gas pipelines. It's just expensive and difficult, but not impossible.
So if you change the hydrogen to liquid ammonia, does the ammonia have the problem of leakage that the hydrogen does in the pipelines?
Not as much, no. It would be like almost the same as methane, if what I'm, and like not the exact same, but if I remember correctly, ammonia leaking isn't as big of a problem, and it's also easier to transport. And especially since ammonia being, when it's in its liquid phase, it's also, you can transport it at ambient temperatures in its liquid phase at less pressure. So that's also a bunch of logistical things that makes transporting ammonia a lot easier. When that pressure decreases, it's a lot easier to transport gases, and hydrogen, you usually have to transport it at very pressurized tanks. So yeah.
So is there this is not one of the, this just came up for me. Is there an advantage of hydrogen, pure hydrogen, as you're talking about it, liquid hydrogen, over ammonia? Or because you said ammonia is more energy efficient. So why would we not convert the hydrogen to ammonia?
Yeah, so any conversion process does take energy away. We were just talking about this in Dr. Bertman's class. We were saying that like because of the thermodynamics, anytime you make in a conversion process, there is some loss in energy from one step to the other. And that's also why you want to electrify everything first, because there's a less energy loss using electricity, and then changing that electricity, using it to make hydrogen, there's some energy loss there. Making hydrogen into ammonia, there's an additional energy loss there. So you have to outweigh it's mostly balancing the costs that people do. So if it costs less to convert it into ammonia and then transport it, then it does that amount of cost, the amount of money you would lose with the energy loss, most people would choose the ammonia conversion pathway. You just have to make that probably in an Excel sheet, do a bunch of math and figure out what's better. Yeah.
Okay.
Steve Bertman had his hand
Yeah.
raised.
Yeah, I
don't-
was going to call on him next. I just saw his hand. Steve?
Yeah, thanks, Nikki. Krystal, thanks for doing double duty with this. I really appreciate it. And my question actually refers to the ammonia. I guess I haven't followed the production of ammonia since, it was invented in the early part of the 20th century. Is ammonia manufactured other than the Haber-Bosch process? And if not, then what fraction of the carbon footprint of the Haber-Bosch process is in producing the hydrogen as a feedstock versus the direct carbon footprint of getting to the temperatures and pressures needed for the Haber-Bosch process?
Oof. You're throwing in the Haber-Bosch process. Can you repeat your question one more time? I missed the middle of it.
We could talk about this offline, but I'm just fundamentally, I guess the question is, are we making ammonia from hydrogen in a less energy intensive way than the Haber-Bosch process? Or
there is one. I forgot what it is called, but I have a different slide about. I make a lot of slides for my job, and I have a different slide on that, so I could quickly look that up after and give you the information and the name of that process. But basically, there is a less carbon intensive process to make ammonia. Yeah.
Okay, great. Thanks. I look forward to that. We can do that offline.
You had that slide that showed all of these projects under construction or anticipated. So what is currently under construction? What is currently in existence? Like how much hydrogen is currently being made versus what is being anticipated on that slide?
Yeah, so if we're talking only about what is being made using green hydrogen, it's a very small percentage. And most of that is currently being done in Europe. Europe is a leader on this. So I would say there's only, and it also depends on the size of the projects. So you saw how, I mean, I could go back to the slide, but you saw how like some of those bubbles were bigger than others, and that was because the megawatt scale of that project was larger. But yeah, basically it's not a lot of hydrogen being made using the green process right now.
You
And
passed
that's,
it.
did I pass it?
Yeah, there.
Well, this is where they're focusing on trying to make hubs.
Okay.
This is not where they're making green hydrogen right now. This is where they're thinking about making green hydrogen to make those hubs. So right now there is only a select few plants that I can even think of that are making green hydrogen, and most of them are just under that project planning phase if they have announced. There's this site called IEA, which has a hydrogen projects database, which talks about all of those projects. And that's probably my favorite site to look into how those projects are going. And they parse it out with this project is already made, this project is under construction. So yeah, the IEA hydrogen database.
Okay. Also, if you're willing for people to contact you, could you put your email address into the chat? Because there are some people that would like to contact you and ask you other questions, non-here questions.
Okay.
And another question that came up is WMU currently has a turbine capable of burning hydrogen. Do you think this would be a good idea for Western's energy usage? And if so, how far would you estimate we are from implementing this usage of blending hydrogen and natural gas?
Yeah. They love to say that, but it's so far away. It's not. You got to do a lot of checks before you blend it. You got to make sure the pipeline's good. Any equipment at the end that is combusting or using that gas, you got to make sure it's good. And like I said, the maximum that they've even tested in like other areas that other than labs is 20%, and normally that's closer to like 5%. So it doesn't offset a lot of carbon emissions. So I would like our energy to be dedicated to other things other than hydrogen blending. Yes, and if we're going to use blending, that is, see, I don't like saying this, but a lot of people say that we should use blending as a scaling thing. So we can do that right now. We can use 5% hydrogen in our natural gas pipelines. And if we increase the amount of hydrogen demand, that will possibly decrease the amount it costs to supply. But is that just going to extend the gas usage in homes, let's say? Maybe that's not the best way to scale hydrogen and to use hydrogen. So I would say, yes, there is a turbine capable of burning hydrogen. It never has. And should it is a question for maybe the community. because I'm actually, as a part of my job, looking into what do we have to communicate to the community when we are introducing hydrogen into their area, and how do we ask for their feedback, and how do we let them know what's going on, basically. Yeah. So I would say, to answer Western specific question, it's hard also because, like I said, you have to worry about where you're getting that hydrogen. And if you're just getting that hydrogen from sources that are being made from how it's being made right now, it's probably not even, it's not offsetting any carbon emissions at that point. So until we get green hydrogen production at scale, I would say using our turbine that's capable of burning some hydrogen is pointless. It doesn't offset anything until we make that hydrogen using a green hydrogen process. So yeah.
Because you're using natural gas to make the hydrogen, so why bother doing the conversion?
Yeah,
That's
you're
basically what
probably
saying.
you're probably releasing more carbon emissions in that whole process. But yeah.
Okay, so if for the people who were interested, Krystal did put her email address out in the chat. You can get it from there. John seems to have his hand up. I don't know if.
Yes, sorry, I'm just, I was the one that was asking about that turbine question. And so I'm just trying to like figure out why exactly they invested in getting this hydrogen burning turbine if it's like basically pointless is what you said. So is there a way for them to burn 100% hydrogen with those same turbines, or is that not possible?
Not possible right now. No, absolutely not. I mean, it might be possible in a lab setting if you had all the safety things, but on the like using it in current pipeline infrastructure, no, that would be terrible.
Right, yeah, no, I mean, like you said, it's such a time focus. My energy is somewhere else now.
Yeah, I mean, like, there would be a lot of like steps to even get it to like using blending. Like you would have to like make the hydrogen in a green way is one step, and then make sure all the equipment attached to those pipelines that you're blending hydrogen is approved for that and is safe. So yeah, there's a lot of steps there.
So
And maybe we should make all of our pipelines leak proof anyway, so less methane gets released in the atmosphere. But yeah.
Well, the basic question that John asked is why did they spend extra to build a turbine that can burn hydrogen? But that's a basic question right now too, is, you know, as we build new infrastructure, should we be making it for what we see coming down the pipeline, or should we only be building it towards what we have currently?
Yeah, I would say we should look ahead. It is good to look ahead. And maybe it was good to buy that in I mean, it depends on a lot of things, because if this turbine has a 50-year lifespan, maybe that is a good thing. Maybe if it was only like a little tiny bit extra money to buy it, maybe that's a good thing. Maybe I don't know the cost of it. Maybe it was like barely any extra. Yeah, basically I would say it is good to look ahead and build towards that. Like currently people aren't doing that enough. Like they're still putting gas burning stovetops in new housing construction, and maybe we should stop doing that. So we should look ahead to, hey, houses are going more towards electrification, so we should stop building them for gas infrastructure. So things like that, we should definitely be looking ahead, even if the infrastructure isn't there yet, so that it's easier to either retrofit or completely switch to a more sustainable energy source. Yeah.
Yeah, you know, a less hypothetical way to ask Nikki's question is, should we be looking towards hydrogen in the future, right? I mean, it seems like there are a few kind of specialized applications that you highlight really well. the steel industry, maybe air transport. That would be hard to electrify. But should we, is it, and maybe this puts you in a awkward position in your job, but should we be focusing, a lot of attention on research and innovation for hydrogen, or should we be putting those resources to direct electricity generation with renewable sources and smart grid?
Yeah, I think we should be focusing on that first. And I would say that, but I also think there are a lot of people that are in that space already. And when I tried to get to that space, it was less research at this point, because a lot of the questions about solar is taken up. So as you said, solar's barely in the research space anymore. There's a couple things here or there. So I guess it's just, at this point, it's more about people have different strengths, and my strength is researching. So I decided to skip the renewable energy and focus on what's coming next. But I do believe that people with other strengths should be focusing more on renewable energy. Yeah.
I realized I had a question. You were talking about brittlement, and you said that hydrogen is being used to make steel, and then later on you said that hydrogen makes steel brittle. How's that compatible?
So it's combusting it to make heat, and that high heat is being used to make the steel. The hydrogen doesn't necessarily come into contact with the steel. Yeah, but there's also specialized steel that you can, like, there's a lot of alloys and stuff, and there's specialized steel that is either less susceptible to embrittlement or not, doesn't embrittle. So it just depends on how you make it. Yeah.